So today we are revisiting the solubility table. If you still remember, we have the Snape rule, we have the Chop's rule. So the Snape rule says sodium, nitrate, ammonium, potassium, ethanoate, when it contains the compound contains any of these ion, sodium, nitrate, ammonium, potassium, ethanoate, it will always be soluble in water. The Chop's rule, we have carbonate, phosphate, hydroxide, oxide, and sulfide. If you come across this ion, there's a very high chance that it will not be soluble. Not always the case, but there's a very high chance. And then we have four other rules that comes with that as well. It talks about group 1 elements, or group 1 elements are soluble, or group 1 hydrides, for example, are soluble in water. Sometimes you will come across chloride bromide iodide. So most chloride bromide iodides are soluble except for silver and lead. So silver chloride bromide iodide and lead chloride bromide iodide. So there's a whole story about solubility, and there's a reason why we are doing that. Because if I go to the next page, which I'm going to do right now, you go through examples. So you did an experiment. You're looking at the solubility of different compounds. So when you're mixing different compounds together, what's your prediction? And that's the reason why we are doing the precipitation in the first place. So let's say if I mix two compounds and these compounds are both soluble, how do we know? You write in equal solution. If you're not sure about how to actually write the compound, you have to go back into the ionic table, to create the ion table, and it tells you the ions. So we have cations, and we know that positive ions, they're known as the cations, and negative ions are the anions. Cats positive, ants negative. So let's just say we look at this example. We have silver, nitrate, and sodium chloride. So both of them are soluble in water. So I've left the solubility table. So observe carefully. And when you dissolve in water, they will swap partners, because the cation will always be attracted to the anion. Positive ion attracts the negative ion. So in this case, you have silver and chloride ions will come together. We have sodium and nitrate ions will come together. All right, when you do your equations, so don't worry too much about balancing. At this stage, you will need to balance the equation. But at this stage, what you're looking for is what will be the product. You can't be possibly getting the same product. Some of them may still join up to the same sort of the positive and negative ion, the same arrangement as before, but most of them would be swapping, the ion. So the cation will always be the anion. So in this case, silver with chlorine, you have sodium with nitrate. So if I'm going to the next page, it will look something like this. So you have silver chloride, you have sodium nitrate. So then you need to go back into the solubility table for you to be able to find out which one will form the precipitate. If you still remember, we say that the second rule, the four rules, if you still remember on the table, it says that all chloride bromides, iodides are soluble in water except for silver chloride bromide iodide and also lead chloride bromide iodide. There's a reason why silver chloride here, it forms the white precipitate. It is solid. You see the letter S is solid because it's a precipitate. Sodium nitrate dissolved in water. So this is how you do it. Then you balance the equation. The number of reactants and number of products have to be same. Same number of silver, same number of sodium, same number of nitrate, same number of chloride. If you are finding, once again, if you don't know how to even write the compound, then you have to go back to the ion table and be able to actually write the compound. It's always a cation joining to the anion. There's no charge because the number of electrons will be distributed between the cations and the anions. If I move on to the second example, we have cobalt chloride and sodium hydroxide. Once again, going back to the ion table. So you have CoCl2. CoCl2, no charge. All right. Cobalt is CO2 plus, chlorine is Cl minus. Together, no charge. So you have two chlorine and you have one cobalt ion within the compound. Sodium hydroxide is NaOH. So when we put this together, we have cobalt chloride, we have sodium hydroxide, CoCl2 and 2NaOH. So partners, cation, anion, cations, anion. So cobalt will join up to hydroxide, sodium will join up to chlorine. So if I show you what is it on the next page, it will look something like this. So you have cobalt hydroxide, you have sodium chloride. Once again, how do we know it looks like this for cobalt hydroxide? COOH, there's a bracket because the 2 applies for the entire OH, OH minus. OH and CO2 plus, OH minus. When they join together, we have CO bracket OH2 and we get sodium chloride. Sodium chloride is stable solid, dissolved in water, but not the hydroxide, the copper hydroxide. You still remember the rules. It says that group 1 hydroxides or group 1 hydrides are soluble in water. It says barium is soluble in water, barium hydroxide, scorpion hydroxide is soluble in water. The other hydroxides are not soluble, not soluble. Copper hydroxide is not soluble in water. Still remember the CHOPS rule. We have carbonate, hydroxide, oxide, phosphate, and sulfur. If the compound contains any of these ions, there's a very high chance it will not be soluble. That includes copper hydroxide. That's how you do it. And let's have the equation. Because on the right, on the left, we need to make sure the number of copper, the number of chlorine, the number of sodium, the number of hydroxides are equal. And that's the reason why on the left we have 2 NaOH, on the right we have 2 NaCl, then we have COOH2. Once again, bracket on. There's not two oxygen and 1 hydrogen, not 2 hydrogen and 1 oxygen. It's 2 oxygen and 2 hydrogen. So it's CO bracket OH bracket 2. And that is how you do it.